Hello everyone, greetings. Welcome to the course Mechanics of Road Vehicles. We are in the lane of CO number 3. Compare the characteristics of different types of governor. In our previous session, we have discussed about the objectives of governor. After that, construction and working principle of governor was discussed. Classification of governor was discussed. There we categorized into two major groups. First one centrifugal governor, another one inertia governor. Centrifugal governor is working on the principle of centrifugal force. Further, we classified into number of categories. Now we are about to explain terms to be used in governor. Next to that, analyze the characteristics of Watt governor and analyze the characteristics of Porter governor. Our unit title is Control Mechanism. In that, we are about to discuss the characteristics of Watt governor. Without terms, nothing will be fulfilled. Now we are about to discuss the terms that we are using in governor. Before that, we have to understand the construction of governor clearly. That is very much important to know. We are having bevel gear at the base of governor. On that we have some foundation to fix the shaft which we called spindle. The spindle is about to rotate in a speed of rotation of bevel gear. The input to the bevel gear will be getted from the output of engine. So the spindle will rotate based on the speed of engine output. On spindle we have some arrangement which we called sleeve. It can move in vertical direction. That is, sleeve can move in upward and downward direction on spindle based on the speed of rotation of spindle. We are having 4 arms which is hinged on spindle and sleeve. 2 upper arms left and right, 2 lower arms also left and right. These arms are hinged at a point which we called pivot points. Another end of arm is fixed with fly ball. It is also called as governor ball or equilibrium ball, whatever it may be. These fly balls can move outward and inward direction of spindle based on the speed of rotation of spindle. If spindle rotates in high speed, the fly ball moves outward direction. If spindle rotates in low speed, the fly ball will move inward direction. Our important term first one is height of governor. It is a vertical distance from the center of the ball to a point where the axis of arms intersect on the spindle axis. It is usually denoted by h. That is the distance, that is vertical distance between center of the ball to upper pivot point, which is denoted as h. Our second term is radius of rotation. It is a horizontal distance between center of the ball to axis of spindle, which is generally denoted as r. Next term is equilibrium speed. It is the speed at which the governor balls, arms, etc. are in complete equilibrium and the sleeve does not tend to move upward and downward directions. Next to that, mean equilibrium speed. It is the speed at which mean position of balls are the sleeve. Maximum and minimum equilibrium speed. The speeds at the minimum and maximum radius of rotation of balls without tending to move either way are known as maximum and minimum equilibrium speeds respectively. If the ball extreme outward position, that is called maximum equilibrium speed. If the ball is at inward extreme position, that is minimum equilibrium speed simply. Next, sleeve lift. It is the vertical distance which the sleeve travels due to change in equilibrium speed. That is, sleeve can move up and downward direction so that the sleeve covers the vertical distance which the sleeve travels due to change of equilibrium speed. The characteristics of Watt Governor are the relationship between speed and height of Watt Governor. As you know that the construction of Watt Governor, that we are having bevel gear and that foundation to fix the spindle, and we have upper and lower pivot points to fix the upper and lower arms. The one end of arm is fixed with fly ball, and this governor makes alpha angle with center axis of spindle. It has a height h and radius of rotation r. As you know that to analyze the characteristics of any system, we have to make free body diagram. We already discussed in our CO number 1, that is force analysis. For clear understanding and easy analysis of the Watt Governor, I just make a free body diagram of fly ball, and it has upper pivot point here. Since it is a equilibrium, because the governor is maintained at equilibrium condition, so that the forces acting on left side will be equal to the forces acting on right side. So that for understanding and easy analysis, I just take left side fly ball. I take a point O as a upper pivot point for understanding, which makes height h and radius of rotation r. Since this governor is rotating and also it comes under centrifugal governor, it makes centrifugal force. The centrifugal force will act away from the spindle, that is outward direction from the spindle, so that the centrifugal force will act on fly ball because of rotation of spindle and governor. It will be in left hand direction. All the components will have some self weight, as well as the fly ball also has some self weight. We just mark this weight as small w and mass of fly ball as small m. Since the gravitational force act in downward direction, so that I make a self weight will of fly ball will be in downward direction. I just mark it as small w. Then we have to take moment about point O to analyze the relationship between height and speed of governor. If you take a moment about point O, there we have two forces, that is centrifugal force will be in left hand direction and vertical force, that is self weight, will be in downward direction. If you take a moment about point O, centrifugal force will make a moment of Fc into h. Because centrifugal force is a horizontal force, the perpendicular distance is vertical distance, that is h. So that moment about point O because of centrifugal force act on the fly ball will be is equal to Fc into h, which is in clockwise direction. Because of force self weight of ball, the moment takes place in anti-clockwise direction, so that I just mark it in minus. I take clockwise direction as plus, anti-clockwise direction as minus. The weight is vertical force and the vertical distance is horizontal distance, that is R. The moment about point O because of self weight will be is equal to W into R, which is equal to 0. Now Fc into H equal to Wr. Fc indicates centrifugal force, H indicates height of governor, W indicates weight of ball, R indicates radius of rotation. We know that centrifugal force equal to mr omega square, that is mass, radius of rotation and angular velocity. Weight of ball equal to mass of ball into gravity, you know that very well. If you apply this in Fc into H equal to W into R, we get Fc mr omega squared into H equal to m into G into R. Just keep omega squared in left side and bring other things in right hand side, so that omega squared equal to m into G into R divided by m R H. We know that omega equal to 2 pi n by 60. If you apply this value in omega point, we get n squared equal to 895 divided by h. The relationship between the speed of governor and height is n squared equal to 895 divided by h for watt governor. Here n indicates the rotational speed of governor, which is in rpm. H indicates the height of governor measured in meter. Thanks for kind listening.